Okay, so prior to our break, we had built up this little model which had a single parameter representing heterogeneity, and we had noted that we could associate draws from a distribution associated with this parameter. I think what we're going to do is to add one more parameter, and we'll use them both within our to illustrate declarative visual properties here. So I'd like you to drag another parameter in, which will be called well, okay, we'll just call it sex, and we'll adhere to the biostatistical convention of denoting it with ones or zeros. Although something within me, from my computer science background, revolts at that thought. Okay, and then the question is it 0 for males, 0 for females, with the general principle that females are better than males. We'll make female 1, males 0. I'm joking. So here we'll have sex, and sex will be 1 or 0. In general, it's better practice to define as what's called an enum. And enum would let us actually say male or female. And I think I'll do that just to keep it a little bit cleaner, okay? I'll show how that could be done. Maybe we'll leave it at 1 and 0. But if we wanted to add an enum, we could actually make this thing so that you could actually say male, it would be male, otherwise female. In order to do that, what I could do is double click on person, and under advanced, I could actually specify additional class code, and I could say enum sex and have male, comma, female. And this will actually provide a way of creating the names, male and female, that mean something. One of the reasons this is superior to just using numerical values 0 and 1 is because 0 could mean male in this context, it could mean New South Wales in another context, it could mean lowest socioeconomic group in another setting. And sometimes it's really nice to have a name for things that's meaningful, and then you can prevent silly errors like trying to assign New South Wales to a person's sex, or trying to add together a sex and two sexes or what have you. So here, what I've just done is I've double-clicked on person, and I've added this thing called an enum. Okay, enum stands for enumeration. And by clicking on sex here, then we can then associate it, instead of with an int, although that would be perfectly workable, we could assign it to an other type and call it sex. Okay, and incidentally, what I'm doing here, you may notice me undergoing a certain ritual here. I'm actually going and doing model build. And in this case, it's actually saying, okay, I don't know what sex is. So I actually have to say, okay, it's sex with respect to person. After all, there may be sex with respect to other classes. For example, deer sexes, a buck and a doe, for example, or what have you. So what I did is, to be clear, I went to person, I added under advanced additional class code, this enum sex, begin curly bracket, male, comma, female, end curly bracket, and semicolon. I put that associated with person, and so when I have this in main, when I refer to that, I'm going to need to refer to person.sex, and in fact, when I have this parameter here, I need to refer to person.sex, it turns out, as well. So now it knows that sex can only be one of two values, male and female, rather than just having an int where it could be, it doesn't know that 3 is invalid for that. So this will provide us extra levels of guarantee. Let's go up to person now, and now we have this population. For the sex here, I could actually draw from, with equal likelihood, either one. So how would I do that? Well, I could use a ternary operator in Java. There's actually cleaner ways to do this in general, but one thing I could do is I could do random true. And random true is a method that I give it a probability, and with that probability it returns true. Otherwise it returns false. Now true and false are designated values in Java. Okay? So if it returns true, so I put this question mark, and this is kind of like an if expression. If it's true, give this value, otherwise give that value. So I'm going to make it random true, 0.5, so 50% chance it's going to be male, 50% chance it's going to be female. This is, I believe, the code that would be required. Let me just double check this. Yes, that's exactly it. So here we have random true. This is something you're going to want to know about. You give it a probability. With that probability, it will return true, otherwise false. So 50% chance, we have a value that's male with respect to this sex distinction as defined in person. Okay? This dot means that it's associated with person. You can think of it as kind of an apostrophe in English. It's person's sex. And then with respect to that sex, the sort of male attribute and otherwise female. Okay? So now we have persons associated with either a male or female sex. Now, this may seem a little bit baroque, but I hope you'll find this. So this is like, again, an if statement. If this is true, then it's this. Otherwise, it's that value. Okay? Like if then else, but it's an expression that determines a value. Any question about that? Yes. No. The spaces are just to make it easier to read. Yeah. And in general, Java doesn't care about space. Now, sometimes that flexibility is welcome, so you can put as much space. Just be aware that normally in Java we use indentation to indicate logical structure as well, but it doesn't really care about it, and so you often will need like curly brackets around things. Just indenting is not enough, and that stands in contrast to languages like Python, where indenting means something logically. Okay, okay. So let's run this. Thank you, Jeff. Sorry. Yeah. Question mark. Yeah. And that's a colon here. I'll thank you for prompting me, and given the expanse of this room, maybe it will be better if I set this, had an alternative sort of way of denoting this. So maybe I'll set it to be 24 point here. So is that clearer? Okay, I'll see if I can keep this in the background so I can put things in it rather than straining people's eyes. Okay, question? Yes? Okay. Okay, I don't... did I give a default value for it? Maybe you're right. I thought I left default blank, but I didn't fill anything in there. Okay. That default value, actually, that doesn't mean the initial value. If I put something there, all it means is that when I create a population of this sort of thing, it'll be filled in with some value. So if I don't specify anything, that's the one that will be used in this field. Okay. So in that case, I left it blank because I knew I was going to fill it in manually. Does that make sense? Okay. Question right now? Okay, so let's run this thing. By the way, that was a little bit of an advanced thing. I cut out a lecture where I talk about these things by doing that. Let's go run this now. So let's run this model, and again, we're not going to have anything visually going on of too much interest, but we can go down to the population using this navigation, and now we see we have people with incomes and this is female. See that? It says female, and then we'll go up, and this one will be male, and this one will be income female, income male. Now, pursuant to a question asked yesterday, I think, there will be times, ladies and gentlemen, where these parameter values are not independent. You're going to want the distribution for one to depend on the other. For example, maybe men and women have somewhat different somewat different distributions for income, in part because of workplace inequality. The whole equal pay for equal work is not yet achieved, and so you'll have disparities because of that. It is possible in AnyLogic to make use of conditional distribution. So we could make use of a distribution for one that depended on the value for the other. But be aware of this. If you want to do that, you have to add them in the order that the conditional dependency applies. So if you were to graph it out using a Bayesian graphical model, you would see, okay, there's sex first, and then income depends on sex. So you'd have to actually add in sex as the first attribute, and then income in that order. And then you can make income depend on sex, for example. Okay, but you actually have to refer to it as self.income if you're referring to it in sex. So the value that you're going to assign to income is called self.income. I'm not sure that's guaranteed in AnyLogic, but it is something which works with the current implementation, conditional distributions. If anyone is interested, I could go into it later. Okay, so now we have these characteristics of people, and we actually have a more helpful way of denoting person's sex rather than 1 and 0, and depending on the vagaries of trying to remember which one is which. We actually have a way of saying male, female. Okay, and that's kind of useful sometimes. Let's now do something a little bit more interesting. Let's go and double click on person and go up to the oval, and we're going to make the oval's color depend on their sex, and we could even have the oval's size depend on their income, for example. But let's go up to the oval, and let's go down to dynamic. You'll notice this is dynamic property, and this is one of the ways AnyLogic gets really powerful for doing things quickly. So if we go here, we'll notice there are all these attributes about this otherwise sort of prosaic oval. So there's all these properties about it that have fields associated with them. And this reflects the fact that we can associate so-called dynamic properties, things which change in the course of a model's operation. We can associate that with code, and it will automatically take care of computing it. Okay. So, for example, we could have the sex of a person depend upon the color depend upon the sex. So maybe for fill color, we could have if they are male, then they're one color. If they're female, then another. So if we have sex, and I'm putting in another of these ternary operators, if sex equals person, equals, yes, it would be person.sex.male, then we'll give them the color blue, otherwise we'll give them the color, pink, something along those lines. So having these two different colors. So what I've done here is I've used that same operator, and I'll put it there. Let me make sure it works fine. Yeah, it's working. So here we go. This is what I put up there. Yes, question? Question? No? Okay, so here we have yes, because that's the name. The lowercase x is actually the name of the variable. Sec. Okay. Okay. So could we go ahead and a question on this? Question? So here what we have is the color. We're basically providing an expression to compute the color. We're saying, okay, if a person's sex is male, we'll use the color blue. Otherwise, we'll use the color pink. Does that make sense? Okay, let's go run this thing now, and we will we'll see, how this appears. Okay, so now we see that over here there's this color, but let's go down to the individual person level. Here's a male, and you'll notice their color is blue up there. Here's a male. Here's a female. The color is pink. Here's a male, female, male. So here we have the color of this depends upon this the sex value. Okay, but right now all of them are stacked together in the upper left. So let's associate now with a location. Okay, so we're going to stop things, and we're going to associate an environment associated with the main class. Okay, so we're going to place a thing called an environment, which will be used to specify a person's location. There's other ways to do this manually, but in a lot of the cases, you could just use this thing called an environment. So where is environment going to live? If it sets the properties of everyone's location, if it choreographs where people live, where is that going to live? Where will we put the environment? We'll put it in main. We'll put it in main. So double click on main. Okay, and we're going to drag environment in from general here. Okay, and we'll just leave its name as environment. Okay, so its name is environment, and this is going to be the key for putting people in context. What types of context? Number one, spatial context. Number two, network context. Okay, so here we have this environment. And you'll notice if you go to the Advanced tab, there's all this information on spatial layouts and network types. We're going to use a spatial layout of random, okay? Layout type random. It's going to be associated with this environment in the Advanced tab. Actually, the default is fine too, but just for sort of completeness. So all we're going to use is their layout graphic spatially, and that's this component. Now we're going to have population here. We're going to go up to population, and we're going to associate the population with, excuse me, sorry, I went up to single click on population, and we're going to tell the population they need to be living in the environment. They need to use the environment we just declared as their environment. They need to get their environmental information from the environment. Okay? So all I did here is I did two things. The first thing is I went to main, and I dragged in environment to main. I didn't change its name. I did go and I set something in its advanced properties. I said it's a random layout. That's actually not important. It turns out not to be required. The second thing is I went over to main again, and I set it so the population uses as its environment this environment I just added with a lowercase e. Okay? So it's going to take all its information about where they're located, who they're connected to from the environment. Is that okay? Questions? Does anyone need help? Okay? Yeah. Are you talking about for... Sorry? The dynamic property for this guy here, for this guy? No semicolon. It's an expression. It's not a statement. It computes a value. It doesn't do something. It doesn't change something. Question though? Static. Oh, okay. I'd be glad to engage myself if required. But okay. So we're gonna now run this model, and I'm watching what's going on. So we'll attend to you soon if this doesn't get resolved. Andre, do I need to come up there? No. Okay. 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 It's just I was the one who defined it, so you probably never seen it before. So Okay, so now we should have something like this visually. Do you see that? Okay. So what we see here is that individuals are scattered around space. They're taking their space from the environment. They're located at different spaces, and their colors are determined by their sexes. We could have their size of this circle depend on their incomes. And very powerfully, we could actually have it depend on things which change over time, like their age. And it would automatically take care of sort of updating over time. Okay, Andre, this young lady has the same issue. Yeah. Okay, so what we've just seen is a situation where we associate an environment, and by that people have heterogeneity in terms of location. Okay, we're next going to go and associate people with. Okay, now right. So we're going to have people connected together. We're going to place the agents in a network. Okay, we're going to first give them a criteria that will, by which it will determine whether or not they're connected. So if we go up to main and we go to environment, okay, we go to environment here, you'll notice there's a thing called network type in the advanced tab. We'll set the network type to be distance based. This is the same type of network that Andre used in one of his demos. So it's distance based, and we'll connect two people if they're within a range of 50. Okay, I think that's the default, so I don't think you should actually have to change it. What did I just do? Well, remember, we have this environment. It's setting people's location. It turns out the environment is responsible in general for aspects of agent context, if we want to use it. And here we had associated population up here. Margot may want to pay attention to this in case it happened while Andre was interacting. We dragged an environment in from the palette here, and then we had set the population, so its environment was set by this environment. So in other words, the population's characteristics, the location of each person will be delegated to the environment. The environment will take care of it. Okay, so I dragged in the environment, and now I'm saying, okay, each person in this population is going to use that environment. By the way, this little thing here, the little light bulb indicates that the environment could differ for different people. Here we're just using one environment. So that was one thing, and now with the environment, we are going to go down and set under the advanced properties the distance-based connection, because the environment takes care of the networks people are in as well, not just their spatial location, but their network context. So we're setting a connection range of 50. Okay. Those are okay. So this is an important attribute of these things. It occurs in one of my slides later. But when we talk about networks, what you'll find is AnyLogic supports a broad range of popular network types built in. Okay. So what that means is that you can just tell it, go off and build yourself a distance-based connection. AnyLogic, go build yourself a scale-free network or what have you. That being said, when you use each of those network types, the information that it needs to build a network of that sort is different for each of those network types. So for a distance-based network, the only one that's required is a connection range. For a neighbor link fraction is actually for a small world network, where a certain fraction of the connections will be directly with your immediate neighbors, but a 1 minus that fraction will be with anyone from across the network. And so that parameter is grayed out right now, meaning we don't have to worry about it right now. But if we were to select a small world network, this would then be enabled, and then we could change it. But it's not relevant for our purposes at the moment. Margaret, did you have a question? Okay. Okay. Anyone have a question here? Yes. Yes. What defines the area over which the individuals are distributed? The area is specified right up here. See, it says width and height. It's in pixels. Each of these squares is 5 pixels across. Each of the small squares. Does that make sense? Okay. And you'll notice there's some more sophisticated things if you have a 3D view, and there's some things, columns or rows, that are relevant for discrete spaces. There's actually several space types, and we'll talk about that later. AnyLogic has several abstractions for space, but this is just one of them. Okay, so we have our environment here, and it's set our locations, and now it's setting our network. So we're going to be connected with people within our networks, okay? Now, we're gonna make a person's size depend on the number of network connections that they have. Okay, so let's. Where would we go based on what we've seen? Where would we go if we wanted to make the circle bigger if they had more network connections and smaller if they had fewer? Where would we go in AnyLogic to do that? Where would we tell it how big that circle could be? Of the circle, that's right. So this is something we want to affect the circle. So if we go to the circle, it's under the dynamic properties of the circle. It's an attribute of the circle. So it's under dynamic here. Okay? Okay, so if we go to the circle, what we'll see is there's a set of dynamic properties associated with it. And one of them is the radius, okay? Right? So we're going to actually make the radius of the circle depicting a given person be proportional to the number of network connections that they have. Okay? They're going to have a certain number of network connections. Okay, so this gets into, we're going to need to put in a little bit of Java. We've actually been putting in Java already. This whole random true thing, that's Java code. Ladies and gentlemen, you are now Java programmers. Those expressions we put in for the enum, those are also Java expressions. Okay, so for the oh, excuse me. Okay, I have to be very careful here. I made a rookie mistake here. I was clicking on this circle to set the dynamic properties. What's the matter with what I'm doing? I'm engaged in a rookie mistake. Precisely. So ladies and gentlemen, the thing that's confusing here is if you go to main, you'll see the circle there as well. But that just reflects, and this gets to this gentleman's question over here, where these people are located. This defines the origin of that 500 by 500 space in which they're located. If I dragged it over here, they would be shown sort of down from here and right from here. Okay? That just shows sort of where the person population will be shown. Let's go down to person, and now we click on that circle, and there'll be a set of dynamic properties for it. We're going to set the radius to be proportional to the number of connections that they have, okay? But we're going to make them at least a certain size. So I'm going to make it a size of 1 plus the number of connections that they have. Now, I want to ask, how many connections does this person have? I need to find that out. How am I going to find it out? Well, it turns out the person will tell me. If I say, tell me your number of connections, it will tell me. How do I do that? How do I say to the person, tell me how many connections I have? Well, I'm associated. This is setting the radius for of a circle for a person. And so I can refer to that person, to the person that includes the circle as this. Okay, that's a reference saying that's the person that I'm currently dealing with. So I could say this dot. I'm saying give me your connection. So I could say get, and I can do control space, and it will actually fill it out. Get connections number. In general, where I have these little fields here, I can do control space. It will try to complete the expression. So here, there's a method, a so-called function of sorts, that I could call get connections number, and it will give me back the number of agents connected to this agent. Okay. Now I have a slide which shows a bunch of common things for this, and if you know, say 15 of these, you'll be able to get by with a lot of your needs. But this get connections number basically says, hey, for myself, how many connections do I have? This refers to me. It's kind of a reference to myself. So I say, hey, how many connections do I have? I say, I have 3 connections. So it returns 3. And then I add that to 1 to get the radius in the x direction. And I'm going to, because the radius in the x and y I want to be the same, I'm just going to paste it into there. What am I doing here? I went to main, I went to person, and then I selected the oval for person, because that's the thing whose shape I want to set. And now I went to the dynamic properties, and I want to set the radius x and radius y for that. Okay? So now we're going to have this person's ovals are going to be of different sizes based on how many connections they have on the network. Okay? What's this network? It's the distance-based network that I declared earlier. So I'm going to run this, and then I'll answer any questions you may have about what's going on here. Okay, so this is what I see here. Why do I see things of different sizes here? Sorry? No, in this case, it's actually connections. The number of connections are different. So the persons, remember what I just did, so it's close, but what I just did is for person, I set their radius x to be this value, their radius y to be this value. It depends on the number of connections. So the ones with very few connections are tiny, the ones with many connections are large in that network. Questions on what I've done? Yeah, I'm sorry. I should have been consistent with that. This is what I did. I put this code here, okay? No, that's a 1. Sorry. It's just everyone appears at least 1 pixel radius, but then for each successive connection they have with a neighbor, it gives an extra width to it. So if they have 2 connections, they'll have a width of 1 plus 2 is 3. Okay? If they have 0 connections, there'll be at least a width of 1. So questions I can answer about this? Questions? What I'm trying to illustrate here is a couple things simultaneously. One is people are now in a network. They're connected to a certain number of people. There's a network there, although we didn't see it explicitly. Our next step is going to be to show this explicitly. So this, ladies and gentlemen, is our network. It has a network behind it. And the fact that they're different sizes is an indication of that. A second thing I'm trying to show, ladies and gentlemen, is that within AnyLogic, just as in a spreadsheet, you can put in a formula that says how this cell depends on these other cells. And if you change anything in those other cells, this thing is automatically computed. You can set properties visually of these things based on formulas. And if anything changes, like if a given person's number of network connections change, that would change the radius automatically. Okay? Yes.
So that's a generic question. So part of the main thing is person and environment. In the rules of the directory, it's the person area is but environment is not interested. Why? Because of
So I think what you're saying is over here, I see 3 components for this model. One is main, one is an agent class, and one is an experiment. Where's the environment? The environment is something that's an attribute of main. Main is sort of the highest level stage in which the agents, various agents circulate, and an aspect of that stage is their location spatially and their connection to one another. And the environment defines that. So it's within main, okay? It's not a distinct solitude from main. It's part of main. And that's one aspect of the entire global system. Another aspect is perhaps the user interface that's evolved. Other aspects might be any data that we're accumulating from the lower levels that will be stored in main, aggregate statistics, those sort of things. Population is in main. So environment is just another thing that's in main as well. Okay? Yes, Andrew.
Can we go through the error that several people have?
Sure. Sure.
Yeah.
So I assume this was in person?
Yeah, that was in person.
Yeah.
So in person we have this enumeration. First of all, using that is it's pretty advanced Java programming, and well, no surprise that several of you have errors in this with this type. Well, first of all, Java is case sensitive, so please keep that in mind. So sex with capital S is not the same with as sex with non-capital S. Several just typed sex and confused two different things. Here we do have the name of type with capital S and a parameter with with non-capital S. So whenever you're referring to type, it's capital S. To parameter is non-capital S. Then this type is defined inside the person class, and therefore when you refer to that type from outside person, let's say from here, you cannot just say sex because it's contained in person. Therefore, you have to prefix it with person. So prefix and dot means you go into the class, and person with capital P is again the name of a class. It's not a particular person and not an agent, but a class of agents. So well, again, this is very, very advanced Java programming. It happened to be in this exercise, so we're going through this these things. So here in main, you have a population of people, and you're setting up their parameter sex, which will be randomly alternating between male and female for different ages. So you're saying here, well, this is a random variable, a random function, and then depending on true or false, it's either person.sex.male, person.sex.female. So person is a class. We go inside the person. There we have defined the type sex, which has two values, male and female, and all these, capitalization of letters is actually important everywhere. You like you see here, sex with non-capital S, it won't compile. What else? In person, is it this person?
Yep.
Yeah. Again, here, sex with non-capital S, it refers to not to the type, but to the parameter. So depending on the local parameter value, the color of this circle will be either blue or pink. And this is a particular value the parameter sex can take. And the value again is male or female. So again, this is pretty advanced, and this can cause confusion especially for people who are not used to not Java really, but this scripting languages which are case sensitive, and several people were confused with it, non-capital, capital,
Yeah.
and all these prefixes.
Very good, very good. So thanks very much, Andre, for taking care of that. That's terrific, and I appreciate the explanation there. So, any further questions? Yes.
You want me to?
Yeah, I was actually going to ask if there's more questions on this at this point. Yeah.
So when you've got the graphical representation with the number of connections with the job,
Right.
the actual person within that block is still the same small size. So like on the picture doesn't mean that it will have more connections. It's just a graphical representation.
That's right. So they're so they're located. I think I get what you're.
They're still located in the same position. They're still the same size. So by them having more connections doesn't mean that
No, no. Oh, I see what you're saying. Yes. So conceptually, they're located at a point. They're located at a point, and that point's location does not change by virtue of this. It's just that we've changed their appearance in a way that's convenient for us to look at it. That's correct. And in fact, you know, if you ran this model as AnyLogic allows without a visual depiction, and that's one option which will lower memory and allow it to execute faster, that won't change the behavior at all, because they're located logically at a certain position, and that's what dictates who they're connected to. Okay, so other questions? Okay, so we have just seen an illustration of AnyLogic's ability to specify a visual representation in a declarative fashion. That is, we didn't have to specify anything complicated in terms of code per se. We provide expressions that test, for example, the radius of a circle. We provide expressions that tell us the color associated with a circle based on the characteristics of the person involved. The number of connections they have for the radius, for, their sex that they're associated with for the color of the circle. Okay. These people are associated in a network, again declared declaratively. Up in Maine here, we have an environment, and this population makes use of the environment as their own environment. Okay. We further seen how their characteristics can be specified using these enums for cases where it's drawn from a couple categorical variables, which, as Andre say, is rather more advanced. I find that my students find it really helpful to be able to look at the actual name, like male, female, rather than 1 and 0. So that's why I included it there. Okay, so the final thing we have to do, which will involve a final push, it's going to be the most complex Java code you're going to see this entire week, is just going to be to link people up. Okay, so we're going to link people up visually. Right now there's a network there, and just as Robin was asking, that network is a logical network. It actually has to do with people's logical position. It has nothing to do with sort of their visual appearance. But we'd like to show visually who's connected with who. We'd like to know what person is connected with one other person. So I'm going to ask your pardon for one final push in this regard. Okay. And from there, you're going to have a model that you could then build atop on for many other exercises. So we're going to give agents a way of appearing visually connected. Okay, they're already logically connected. That's why some were bigger than others. We could have an infection spread model given what we've had, but it's often clearer if they're visually connected to one another. And if you open a wide set of AnyLogic models, you will see them visually connected. And I want to demystify that. There's no magic there. It's actually quite straightforward, but it will involve a little bit of additional work here. Okay. So how are we going to do this? How does AnyLogic show these things as connected in their example models, or those models that you've gotten from me? How is it that people appear connected? Well, it all boils down to a few simple elements put together in an artful fashion. Okay. So what we're going to do is we're going to go to person and open up person. And just as a person has an appearance in terms of a dot, they're going to be associated with a line as well. Okay, here's a line, and I've just dragged from the presentation area of the palette over to drag it over to center on the circle. Okay, now to do that, you may notice that this line has two ends. One has a plus symbol on the end, and one has a dot on the end. The line comes from the plus symbol. So when you drag it over, you want to have that plus symbol land atop your oval. So let me drag over, and it's actually where the mouse is. So as long as we put the mouse right in the center, we'll be fine. Okay, that's a connection. It's going to serve as our visual connection. This is going to be the thing that visually connects multiple people. So when we see the network, it's going to be composed of this line. and that line is therefore going to show the depiction. So it should look something like this. The key thing is when you drag over, you could just put the mouse over it, and as I said, you'll be fine. Okay, so that's step one. We've associated people not only with a circle, but with a line. Okay, and if you're unsuccessful initially, drag the plus side to the center. So from the model now, we will see what appears to be a field of lollipops. Here we go. We're gonna run this thing, and we'll see an uninspiring sight. Well, I don't know if it looks like that. Maybe it looks like meteors or something. But depending on your orientation, needles. Okay, so what's the matter here? What's missing? What do we need those lines to do? Okay, they have to connect to the thing we're connected to. There's no connection. But how if we're connected with more than one other person? How if we're connected with two people? Which of them does the line go to? That's a trick question. There's got to be more than one line. There has to be one line for each person we're connected to. Right? Stands to reason. If I'm a given person and I want to be connected, and I have two neighbors, logically, I want a separate version of that line for each of them, right? Okay. So we're going to go through and do that. So we need to multiply and then adjust the lines to connect, okay? So this is where little bits of code are going to come in. So what we need to do is we need to so-called replicate this line, okay? We need to have a copy of this line for each neighbor. That's the first job. Does that make sense? If I have two neighbors, I need two copies of the line. Does that make sense? Okay. So, ladies and gentlemen, earlier we wanted to set the properties of the oval. We wanted it to appear color to change based on the person's appearance, person's sex. We wanted its size to appear based on the number of connections. Where did we go specify those things? Where did we go define what its size should be for the oval? Where did we go define it? What did we go to set that property? We went to the of the person agent's what? Their presentation, what particular element of the oval? We wanted to change the characteristics of the oval, so we went to the oval to specify. Incidentally, this is a reflection of this notion of sort of object orientation. It's a characteristic of the oval, so we go to the oval. The oval's responsible for its own presentation. Okay, so to set how many lines there are, we're going to go to the line, to this thing that we dragged in, the line. So we click on the line, and you'll see there's actually a field under dynamic called replication. That's how many copies there's going to be of this thing. And we actually entered the right answer for this. How many copies do there have to be? If I have one person I'm connected to, how many copies does there have to be? How many copies total? There has to be one copy. If I'm connected with two people, there has to be two people. So it's based on how many connections I have. Where did I enter that before? Does anyone remember? I had an expression that gave me how many people I'm connected to. The get connections number was associated with the size of that oval. So I actually already put in the thing that does that. The logic. It's this get connections number that returns how many connections I have. Remember that thing? I'll put this up in the bigger window in just a second. So when I go to the replications property of this line, it's replicated a number of times of get connections number. That's what it should be. Does that make sense? So this line is going to be copied this many times. It's going by copied, I mean you click on the line and it's under replication of dynamic properties. Does that make sense? Okay. Replications of it. Okay. So that's the replication line. So that's a good start. If I have two lines, if I have two connections, I have two lines. Three connections, three lines. Great. The other job is what? I have to have them go to the right place. And each one has to go to a different place. Right? each one of these lines has to go to a different place. The first line has to go to the first person I'm connected with. The second line has to go to the second person. The third line has to go to the third person. So we're almost done, but we're going to do a little bit more here. Few tips to keep in mind when we're running this sort of code. There's a light bulb next to it. Be sure to look at the light bulb because it may tell you some useful things. While typing the code on a PC, you can hold down Control and space. On a Mac, I can't remember, it's Command space or Apple space or what have you. Java is case sensitive, as I noted earlier, and as Andre noted. And if any of you are so interested, you could press Control J on a PC to go to the point in Java where it's actually uses the appropriate thing. So you can see the context in which it ends up being used. Okay, so in this case, we can go to the DX property, and if we go and we look, it says use index of replicated line. So I can actually, when I'm giving a formula for DX, how far over this line needs to go in the X direction, I can actually know if it's line 1, line 2, line 3. Actually, it starts at line 0 by the odd conventions of my kind. A computer scientist, you can know a computer scientist from a mathematician if they like to start things at 0 and start lists at 0 instead of 1. Gives us away. A lot of us sort of can play for applied mathematicians for a while. But that will show us for sure. So there'll be line 0, line 1, line 2, and index will be the number of the current line we're dealing with. So we're going to have a formula which is going to tell us how far we have to go over for the 0th line, for the first line, for the second line. We're going to have to insert that formula. Okay, and this is the last of the complicated formulas that we're going to be entering. This will be the most complicated thing we'll be doing. Okay, so let's reason about this. If this is where we are at the red, this is our index agent, and we have to go over to another agent, we're going to say, okay, our position is XA, YA, so the X location is horizontal, and our X location is XA, and their X location is XB. What's the delta here between them? How far over does this line have to go? What's the length of the line, the X direction? The displacement has to go in the X direction. It's what? This minus that, right? So if XB is 1, just 1 greater than XA, it has to go over 1. If it's 2 greater, it has to go over 2. So it's XB minus XA. Does that make sense? And the same thing with Y. YB minus YA. So we're going to have to estimate. That's what this dx to dy is, okay? So we're going to need to give a formula which computes that. We put down a formula that computes that. Okay. So how are we going to do this? Well, we have to find out who this person is, and then we have to ask for its x location. We have to find out who they are, ask for the y location for each of those, okay? So that's the sort of logic behind it. I may come back to us, but to get a reference to the ith person we're connected with, if we're an agent and we want to find out who's the 0th person we're connected with, we can call get connected agent of 0, and that will give us back a reference to that agent, so we can refer to that agent. Then we can ask it, what's your x location? It will tell it to us. I could say this.get connected agent 1 and ask what's its x location. That would be the second agent I'm connected to, 0 and then 1. So we can ask, if we have a reference to an agent, we can ask .getX, and that will return to us its location. So if our position is this.getX, that's my x location, and then the agent we're connected to, the 0th agent, I could call this.getConnected agent of 0. That will return a reference to that agent, the 0th agent. And then I can call getX on that, and that will get its x location. This is me, and I'm saying, hey, get my connected agent, the very first one of them, so at index 0, and now get the x location of it. Does that make sense to people? So this is my location, this dot get x. I ask myself, what's my x location? And I'll return a value. And if I want to find what's the x location of the person I'm connected with, say it's person 0 of my persons that I'm connected with, I could say this dot get connected agent of 0. And that will give a reference to that person, and I can ask it what its x location is. So that's going to give us the formula. This is going to define the formula of those two things. It's just the difference between this guy and our x location. So where did this index come from? This index thing? I actually mentioned it just a minute ago. But it's something provided by AnyLogic. Remember, this line has many copies. Copy 0, copy 1, copy 2, enough for each of our neighbors. Index is the number of the current line we're dealing with. Each of those have to be put to point to a different neighboring person. So the 0th one will point to the 0th person we're connected to, the first to the first person, etc. So this index is provided to us by AnyLogic. We're providing a formula that tells us for a given line of number index to what other person, or what's the x displacement we have to use for that line. So the formula for this is simply this thing here. This is the location of the other person in terms of x coordinate. We subtract off our x coordinate. Okay? And this is the location y coordinate. We subtract off our y coordinate. So this top one gets into the dx, the bottom one goes into dy. Okay. So that single line visually that we added, it gets replicated a number of times according to the number of people to whom we're connected, and this gives the formula for a particular index of that line. A particular copy of that line is denoted by index. How far over does it have to go x? How far over does it have to go y? And that, ladies and gentlemen, is the most brutal of the things you will do during this session, during this 3-day session. This is the sort of most complicated logic. Okay, so I'm going to leave that up there. For those who are interested in understanding a little bit more what's going on, this is referring, it's a reference to me. And if I have that reference, I can get values for myself, or I could call a method. One of the methods I could call is getConnectedAgent. That will return a reference to a different agent. And then I can call this getX on it to get its x location. We have these references to objects in Java, and we can interrogate them by calling methods or by getting values from them. Okay, so that's as rude as it gets in terms of Java exposure for this session. Any questions about this? Yes? Oh, you mean here? Dx, dy? Okay, it may be because the agent is a, perhaps somehow it was associated with a 3D agent. Yeah, so could you, if you go to environment, what is the space type should be continuous 2D under main, if you go to environment? It is, okay. Okay, so I'm looking at things that might affect that. Okay, Robin, if you go to person and you go to the agent tab and in properties agent, up at the top, does it say space type continuous 2D? Sure. So in person, if you select person and you go to the agent tab under space type, does it say continuous 2D? It does? Okay. Well, I'm I'm a little bit baffled by that. This is, Robin, is it possible you're looking at x and y and not dx, dy? So, folks, we're filling in dx, dy here? Okay, is dz, is that grayed out? Okay, grayed out is fine. Grayed out is fine. I'm sorry. This is actually an AnyLogic version change thing, because I actually made the screenshot with AnyLogic 6.2.2. Yeah, no, I appreciate knowing about it, and I'll have to retake that screenshot. Such is my life. Yeah. So okay. Okay. So this is what I put in. I just put in the code that was there, and if we run this now, what we should get is a depiction with people and networks. Do people see this? Okay. So again, I have to apologize for dragging you through that. I hope it'll help you give some indication of the sort of Java coding that's more or less inevitable in AnyLogic, some measure of that. And I hope some elements of that logic make sense to you. This notion of this being something I can refer to my own properties and ask, like, what's my x location, what's my y location, by calling methods on me. And also the fact that I can have these visual properties and have specify their properties using just expressions, and it will take care of this. Okay. So that's an interesting aspect of this component. These sort of components. We're going to now do a little bit more before lunch here, and then we're going to break. We're going to do a state chart, okay? We're going to do a state chart for this agent. So now we have these agents in these networks. It's all well and good, but we're going to start adding in some additional logic that describes the behavior of agents. Any questions about this before I switch to that? Yes, yes. So there's a model, and in fact, I think in this next one, I even say to load in one of the example models that I provided. So it's called Minimalist Network ABM Model. You'll find it in your set of example models. For those who have built this up, you're welcome to continue on with your model. But it's called Minimalist Network ABM Model, and it should be one of the examples provided. On the on the thumb drive provided.
Under example models,
Did you find that? Okay. Sorry. Okay. Okay. Thanks. Yes. Yeah, so this is a known issue under certain circumstances that I've observed. Are you doing any recording of your screen or anything like that? No? Okay. Is it a PC or Mac? Okay. I'll have to go frob it later if I can. Okay. Model. No, it's Minimalist Network ABM Model. Just so, yeah. Okay. Okay. So now what we're going to do is we're going to take this model that you've loaded in, and we're going to go add a variable into it that's going to actually represent the color. So to this point, we've had color represented by just in terms of sex. We're gonna have a different version. Okay, so we're going to drag in a variable called color. Okay, now learning from the early experience, this color should be lowercase. See, and it adheres slavishly to American spelling convention, in defiance of the common shared convention of the Queen's English aspired to in both of our fine nations. So I'm omitting the U in deference to the American Imperium. So COLOR in a lower case, okay? Now, this class is going to represent variables that are not doubles, they're not integers, they are not a Boolean, they are something of a class color that defines colorness. In the same way person defined personness, this color is defining colorness. So it's a class with capital C, OLOR. Again, using the conventions of American spelling. Okay. So here we have a variable that's going to represent our current color, and that color is going to change over time in accordance with our state. Okay, so this is a variable, and initially, unless it's specified otherwise, we're going to provide it with a value of black. Okay, we're going to start with a black value until told otherwise. Okay, does that make sense? Color. This is. I'm sorry. Sorry. This. Oh, I just dragged a variable in from general. A variable. This is just a variable. Up in the very topmost thing called general. We could drag a variable in, and we'll call it color with a lowercase c. Do you see that? Okay, yeah, no, it's variables can be for all sorts of things. We could have a variable for our current weight. We could have a variable for our income over time, changing over time. We could have a variable for our current educational level. Often it's associated with something which changes over time, in contrast to parameters, which more rarely change over time. Okay, so here we have a variable. A parameter typically. A parameter provides two things. It provides a way of communicating assumptions to us on the one hand, and it typically doesn't change frequently, so it's more or less constant in most cases. A variable, by contrast, will be often changing over time. Okay, so I'd now like you to set the color of the oval to be color. How do we do that, folks? Just drawing on what you've done. How are we going to set the color of the oval to be the value of color? Where do we go to do that in our model? We select the oval. This is one of the most important things people have to learn to do in AnyLogic. A reason about where things are, because there's a lot of things scattered around. AnyLogic provides a great tool for generating documentation, which will help you find where things are. And I'm going to have to find where that is here. But in any case, it provides a great tool for summarizing things. But in general, you're going to have to learn to think about, okay, where would I go to do something? Here, if we're going to specify the color of the oval, we need to go to the oval. And for the fill color, we're going to get rid of this earlier expression and just put in color. We're going to use whatever value is in color. Instead of computing it based on our sex, we're going to just put it in color here. Okay, so that's good. You know what I think I might do, just for completeness? I'm going to copy this nice little line that we put in at great expense. Instead of just blowing it away, I'm going to put it into line color down there. So we'll have the circle around us be the color of the person's sex, and we'll have their fill color be dictated by this color. So it'll still indicate their sex. It'll just be down under line color. Okay. I know some of you, this was hard fought, and therefore I'm putting it down in under line color. Okay. Okay. In case you have to type it again, I'll put that up there in this thing. Okay. So that was the thing that goes under line color. It goes down here under line color, and then under fill color we have a reference to color. Whatever value is held in that color variable, that's the one that will be used for our fill color. Okay. Any questions? Okay, let's run this thing. How will this differ from what we've seen before? Those who have loaded it in actually will see a slightly different thing in the sense you won't have these different things. But here we have the different colors, and you'll notice actually the border of them is either pink or blue. If you zoom in enough, you can see that. I just did control wheel, and I can kind of zoom in and see this border and so on. Okay, control the mouse wheel in. Okay, good. So now we're going to represent a state chart. Okay, and this state chart's going to be very simple at first, and we're going to elaborate it. So we're going to add an entry point for the state chart. The state chart is going to depict discrete action over time. So we're going to pull in a state chart entry, and this is going to be called infection state chart. Infection state chart. I'm going to, just to be consistent with the slides, although I don't like it, I'm going to capitalize the I for infection. So infection state chart with a capital S. Okay. And all I did is I went down to state chart area of the palette, and I copied in the state chart entry. Okay. People okay with that? Questions? Confusions? Okay. Okay, now let's drag in a state. So we're going to put in our first state, and this will be the susceptible state. Okay. Susceptible. I forgot the P. Now when I go and I modify that, actually it will tell me, okay, I could go correct all places where that name originally appeared if I press Control Enter. I'm not going to do that because I know it only appears once here. But just be aware that if you go and change the name of something after you have lots of things referring to it, it can automatically change all of them very nicely using Eclipse's refactoring tool. Okay, so here we have susceptible as our state, and we want to make sure that when we drag in susceptible that this guy appears really connected to it. There should be a green connection. If we click on this, there should be a green connection. That's an indication you're A-OK. Okay? And when they enter that susceptible state, we're going to set their color to be green. Okay? And AnyLogic is a little bit inconsistent with when it absolutely requires semicolons and when it doesn't. Here, I'm not sure, but in the interest of consistency, we're just going to put a semicolon. This is a Java statement. It's different than a Java expression. A Java expression is a formula. It gives us a sort of a mathematical formula that specifies how do we compute something. A statement does something. It has a side effect. It changes the current state of things. Here it's assigning the green color to the value color. Okay. So we have the value color now. Green is our color. What will that do visually to us? When you put 2 and 2 together, when we assign green to be the color here, or the color to be green, what's that going to do to our appearance? Sorry? Yeah, it'll be green. How does it know to make us green? What do we do? Why is it that it knows how to make us green? Yeah, the color associated with this oval. Remember we said for the fill color, use the value of this variable color. So as soon as we enter this state, it's going to set, ooh, did I? Oh man. I'm sorry folks, I meant to put this in the state when we enter the state. So we can have an action associated with the state. When we enter the state, we're going to be in exactly one of a set of states, collectively exhaustive, mutually exclusive states. And when we enter one, here there's going to be an entry action that's going to set our color. We can set an exit action. When we leave, we do something. Here we're going to set our color to be green. Okay. And now we're going to add an infective state. Okay. Infective. So we've just dragged in a second state. I've done that again from the state chart area of the palette. Does that make sense? So I've just named it infective. And for this guy, I'm going to set color equals to red. Color equals red. Okay? See that? So for this guy, when you enter the infective state, we're going to update our color to be red. Questions about this? It's entry action. So when we come into this state, we're going to do this thing, namely update our color to be red. So as soon as we enter the infective state, we're going to be a pure red. Does that make sense? Okay. Next, we're going to put a transition between these two. To do that, you drag out, it is directional, position it so that it goes from susceptible to infective. I'll do that again so you can follow it. So you take this, you drag out like this, and I can actually kind of just move it onto this bottom one and kind of just push up the top. It's very nice. I'm sure a lot of logic went into that. And you'll notice it's green on both sides. That's an indication that it's a happy camper. So it's connected properly. Also, the problems window would show difficulties if it didn't. Okay, so we've just this transition, and these transitions specify the logic, the conditions under which we'll go from one of these states to another. And there's several types of transitions. Timeout transitions, where you leave after an exactly a certain period of time a fixed rate, which is a hazard rate, can be fixed or actually can be changing over time, though you have to be careful about that. It's a memoryless process if it's fixed, so no matter how long you spent there, you have the same chance per unit time of leaving. So it's a probability density of leaving for whom that's meaningful, a hazard rate. We can have a variable rate that's changing over time. We can leave if a message is received or if we've arrived at a certain destination in our mobility. And these transitions can be routed to different branches. Okay, so here we're going to have a fixed rate transition, and the fixed rate transition is going to be 0.01 initially, okay? So it's going to be a rate of 0.01. So for this transition, which I'll call infection, and I'll show this name, we're going to have a rate of 0.01. It's okay? Okay, so let's run this model. What should we see? By the way, when you build up models, I very much encourage you to do this in a highly interactive way. Test it because you'll spot errors quicker this way. There'll be less you've done since the last time, so if there's an error, you know where it is more tightly. Okay, so what should we see if we run this model? Okay, good. Do they all go? So here we have two that are red right now, and over time, more are becoming red. Why is it that they're changing color? Give me two reasons. What are the two reasons they're changing color? Because why are they changing from red to green? What's happening? What's leading them to change color like that? Okay, yeah, so the connection fires off, they enter that state, we set that variable to red, and then remember we set the oval, we set its color to just depend on whatever value's in that variable, so it automatically updates. So the longer we run it, more and more of these will be updated. Okay, so that's a rate transition. By the way, this is the little name of this. Ooh, hey, this is, hey, come on. This name, let me select this, and that allows me to move the name here. And you can do the show name, it'll show its appearance. Okay, so here we have these transitions going on. Let me ask, and so you want to basically check connectivity of transitions. We're going to be finishing in just 2 or 3 minutes here. But let's talk about, so I go into some of the theory behind this. Again, it's a memoryless process with fixed hazards if you have a rate transition. So the average amount of time that you're in this state is 1 over 0.101. For those who are familiar with system dynamics, this is very similar conceptually to a first order delay, except that each person is in one state or another state, but their likelihood of remaining in susceptible state declines exponentially over time as e to the minus 0.01 times time times the amount of time since they got in there. Their chance of leaving per unit time is the same, so it's memoryless no matter how long they've spent there. This is a very common means, and again, they have an average time there of 1 over that. So the average amount of time is 1 over the hazard rate and vice versa. Okay, so here we have these transitions. What if we made this instead a timeout transition with the same average time till leaving? So the average time till leaving was 100. It's 1 over 0.01. I'll make it more explicit. What if we had that? How would this be different visually? Sorry? Aha. So let's go run this. Does that make sense to people? A timeout of exactly 100. So at what time would they all go together? At time 100. So here they are. Time is moving on. Really, very little is going on. Watch this. 60, 70, 80, 100. Boom. All gone. So time 100, they all switch together. In short, they all leave after exactly 100 time units after they got into susceptible. Here, everyone gets into this state at time 0. Okay, so here we have a model where there's dynamics going on. There's a color that distinguishes their current state, and you see it. The final thing we're going to do here is to add a decay transition, so a natural recovery transition. So we're just going to drag this thing over just to give a bit of space. It doesn't affect things logically, just in terms of the appearance. And we're going to have this transition go back from infective to susceptible. I'd like this to be with a rate of 0.1, okay? A rate of 0.1, okay? Oops, 0.1. So in other words, we can go back to the susceptible state through, say, natural clearance with a rate of 0.1. So on average, we stay with the illness for 10 days, 1 over 0.1. I want to change this back from a timeout to a rate coming into here. There's just to standardize things. So we have a rate coming in and we have a rate leaving. Okay. Okay. So if we run this, what should we see now? Anyone? What should we see? How does it differ? There we go. So what are we seeing? We're seeing people oscillating between these two different states. And if we stop it at any one time, if we were to pause it, well, in fact, let's not even pause it. Let's go down to the to a particular person level. And what you'll see is actually at a person level, this one's flipping between these two. I don't know if you can pick it up on your screen up there. Can you see that? It's sort of this particular person 0 in the population is sometimes susceptible, sometimes infected. We'll slow this down a little bit. I'm going to leave what's called virtual time mode, where it's as fast as the computer processor will allow it to go. In short, it goes flat out. But we're going to instead do it at a somewhat slower rate. I'll do it at maybe, I don't know, 25 times, something like that. You'll notice that this thing is sometimes in one, sometimes the other. It's just alternating between them. You notice there's also these characters. Well, for those who built up the model, also there's those other characteristics. You'll notice also it shows the person, this particular person, where are they in the population? See that visually? And if you click up, this other person will be at that location, this other one at that location, and you can kind of browse through their visual locations here, the number of people to whom they're connected, etc. Okay, so state charts. We've just built a state chart. This is not nearly as sophisticated as it could get. Material I'm not covering will include, for example, branch transitions. These are very, very helpful if you want to start the model. Some people in one state, some people in another state. You could have them branch when they come into the model from part go to one state, part go to the other state. These sort of Decision points can be used further, these predicates to figure out, say, if someone's infected when exposed, etc. And I'm not talking about hierarchical state charts, which provide a whole level of detail. I'm not introducing parallel state charts, say for different conditions, comorbidities, which evolve in parallel. Trivial to do, no problem to add them in. You can add as many state charts as you want, and you can have them influence one another by, say, updating each other's rates of transitions, etc. I'm not covering that here. There's some more subtleties here with changing rates over time, cases where my chance of leaving the state maybe for each successive day rises with each successive day. So maybe my chance of developing cavitary TB rises with each successive day I've had untreated TB, for example. And hierarchical state charts provide a very convenient way of characterizing shared transitions. Rather than duplicating them for each of a set of transitions, we could capture a single transition out for a whole bunch of internal states. And there's a very nice model, the predator-prey agent base, that will illustrate that. I have some suggestions on code that's useful. One of the most important is being able to ask, which state am I in, and doing something different based on that. This is all in the notes. I don't have time to go over this, but I would like you to be aware that state charts characterize situations where a person's in a discrete set of states. The most low-level states are either in one or the other. They're collectively exhaustive, mutually exclusive. There's a set of different transition types, rate transitions, timeout transitions, transitions triggered by messages, condition transitions. If the stock goes above a certain value, I will then transition to a dead state. If the stock of viremia, of free virions goes above a certain level, I will die. There can be transitions based on message arrival and transitions based on arrival at a location for mobility. All those are there. We don't have time to go into them. That was state charts. Any questions on that? Yes? Yeah. Yeah. Yes. Yeah. 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 Yes. Yes. Right. Well, okay. So you can choose your time units accordingly, but everything has to be consistent with respect to it. You don't want to use in the same model one hazard rate that's a chance per year of dying, and another rate that's a chance per day of recovering from an illness or something like that. You want your rates to be all with respect to the time unit of interest for the model. Okay, and that being said, you could choose your time unit of interest. With calendar time, you're absolutely right that you're making use of a time unit that's dictated by the calendar, and that's sometimes very useful because you could ask what day of the week it is, and sort of throttle things accordingly. I think we should break for lunch. I'm glad to talk more about this or answer further questions after lunch.
It's mercifully we have an hour lunch starting at 1.
Starting at 1? Restarting.
Restarting at 1.
Okay.
So I'm thinking